right, this is called dividing rational expressions. And we're not going to do too many examples because, like I said, it's just like the multiplying rational expressions. It's just you got to do one extra thing. Okay? So we are going to divide, and we're also going to state the excluded values of each. So example 1, we have r minus 10 divided by r plus 10. That's my first fraction, r minus 10 over r plus 10. And that is being divided by r squared minus 16r plus 60 all over 54 minus 9r. So we still have to factor everything. Factor all my numerators, factor all my denominators if they are not already factored. The one additional thing that we have to do, y'all know, just like when you're multiplying regular fractions, you, I like to call it keep, change, flip, but that's not the technical mathematical word, so I'm really not supposed to use that. But keep the first fraction the same, change the division sign to multiplication, and write the reciprocal of the second fraction. It's a lot longer to say, right? It means keep, change, flip. But we got to keep, change, flip. And then after we do that, everything else is just like multiplying, okay? You can factor before you keep, change, flip. You can factor after. But here's what I notice. When students factor before they do the keep, change, flip part, they forget that they didn't do the keep, change, flip part. You know what I mean? Because they already did so much work, they totally forget about that. So my suggestion is to do that first and then factor. Now, in my notes, I'm not going to write keep, change, flip, because like I said, it's not the technical mathematical terms. I'm going to say, step 1, keep the first fraction the same, comma, change the division symbol to multiplication, and write the reciprocal of the second equation. Keep the first fraction the same. Change the division symbol to multiplication. Write the reciprocal of the second fraction. Keep, change, flip. After that, it's just like multiplying. So keep my first fraction the same. I'm going to rewrite it. R minus 10 divided by the quantity of R plus 10. Can I cancel those out, by the way, R minus 10 and R plus 10? No, they're not identical. Change the division symbol to multiplication. And write the reciprocal of the second fraction. So what's in the numerator goes in the denominator. What's in the denominator goes in the numerator, right? So my numerator will now be 54 minus 9R. And my denominator is R squared minus 16R plus 60. So now everything's just like we learned already. That's literally the only difference, literally. Okay, and then our excluded values as well. Okay, so I'm going to multiply the whole numerator together, but I'm not actually going to multiply yet. I'm going to put it all in the numerator, but I'm going to write the factored form, right? Because I might be able to cancel a lot of stuff. So my new numerator, well, R minus 10. Can I factor R minus 10? No, it's linear. It doesn't have a GCF. So it's already factored. There's nothing to do there. A lot of lag time today. 54 minus 9r. Well, first of all, that's not in standard form, and probably not in standard form because the leading term would be negative, and they don't like that. So let me bring that over here to the side. 54 minus 9r. It'll show up any minute now. Maybe. I wrote it under the words from the steps. There we go. So I'm going to rewrite that in standard form. The negative stays with the 9r, so it's minus 9r and 54 is positive. Even if there was not a common denominator, you want to still divide out a negative. When that leading term's negative, you want to divide a negative out. But you also have a common factor of what? 9. So I'm going to factor out a negative 9. So what's negative 9r divided by negative 9? Not negative r, so we factor r. And positive 54 divided by negative 9. Negative 6. What's in parentheses? That's linear. It does not have GCF, and so it can't be factored any further, right? So I've got a negative 9 as a factor, and I have an r minus 6. That's a factor. That's all going in the numerator. You will see it sometime today. There we go. My denominator. I'm going to multiply that all together, but first I'm going to find the factors of everything. R plus 10, can I factor that? No, it's linear. It does not have a GCF. So it's already factored. I'm just going to bring it on over. Bring it on over. Now, r squared minus 16r plus 60, that's quadratic. I can probably factor that. I'm going to do that over on the side. What is A equal to? 1. What is B equal to? And what is C equal to? So on a little T-chart, I need two numbers that multiply together to get A times C, which A times C is positive 60. And on the right side, I need two numbers that add to give me B, which is negative 16. All right, let's see. Negative 10 times negative 6 is positive 60. Negative 10 plus negative 6 is negative 16. Sweet. And am I going to need to divide and slide? No, so I'm just going to go up to my problem and write my factors. So I'm going to have a r minus 10 and r minus 6. Coolio. Now we know we can't see it. We're going to cancel anything we can. Let's see, I can cancel r minus 10 from the numerator and the denominator. I can cancel r minus 6. And that's it. So left in the numerator, I should have a negative 9. And I can put that negative right next to the radical, or I can put it in the numerator. And then in the denominator, all I have left is r plus 10. Now, when you write your restrictions, look at the, and I'm questioning myself about this right now because I'm looking at the answer key and they only have the restrictions as positive 10, negative 10, and positive 6. But see, if your original problem, the 54 minus 9r, well, that would be correct. I believe you have to write your restrictions for anything that was ever in the denominator, okay? So, well, we know, look at where we have factored. R plus 10, R minus 10, R minus 6. So we know R cannot equal negative 10, positive 10, and positive 6, right? Well, 54 minus 9r was originally in the denominator, was it not? So it was at one time in the denominator. Well, 54 minus 9r, that was factored to be negative 9 times r minus 6. Well, so that would have given us a restriction of positive 6, which we already have that. So that's why I'm questioning myself, because either way, the positive 6 would show up. But I'm almost 100% positive. I need to go back and look at my old notes. When you're doing the restrictions, look at the denominator. Anytime something was, an expression was in the denominator, you can get a restriction from it. All right, so that's my answer. Yeah. Yeah. If a number does not have a variable with it, it won't give you a restriction. Because if I set negative 9 equal to 0, it can't equal to 0. You're only going to get a restriction from factors that have a variable in them. Okay? So like if there is never a variable in the denominator, it's just numbers, because I know on yesterday's homework, some of them just had numbers in the denominator, you won't have any restrictions. Because there would be no way to get a 0 in the denominator if there's no variable. Know what I mean? All right, example 2. Anybody have a question about, any other questions about example 1? All right, let's do 5x minus 15 divided by 9x. So that's your first fraction or rational expression. 5x minus 15 over 9x. This makes me crazy. Really makes me crazy. All right, and then that will be divided by x squared minus 8x plus 15 and that is being divided by 9x. So right now, what are my restrictions so far? X cannot equal what? Not negative 9, because 9 times negative 9 will be negative 81. 0. But we're also going to get some restrictions from x squared minus 8x plus 15, because that's going to be going to the denominator. Okay, so it's not currently, and usually you don't get restrictions from your numerator, but it will end up in the denominator, so we get restrictions from that too. All right, so first fraction stays the same. I'm just going to rewrite it. Change division to multiplication. And y'all don't need to see this. You can hear me. You know what to do. The second fraction, write the reciprocal. What was in the denominator goes in the numerator. What's in the numerator goes in the denominator. So we know when we multiply fractions, we do numerator times numerator, denominator times denominator. But I'm not technically going to multiply yet. I'm going to factor everything, but I'm going to put it all in the numerator. So 5x minus 15 is linear. Only way to factor a linear expression is if it has a greatest common factor. Does it? Yeah, what is it? So when I factor it out, what am I left with? X minus 3. Okay. 9x is a monomial. We don't factor out monomials. I'm just going to bring it over. So in my top now, I have 5 times, open parentheses, x minus 3 times, open parentheses, 9x. And the denominator of a 9x, well, it's a monomial. I mean, I could factor that to 3 times x, but it's not necessary. X squared minus 8x plus 15. Okay, that's a quadratic. I'm going to do that over on the side. We know that a is 1, b is negative 8, and c is positive 15. So in my t-chart, I'm going to need 2 numbers that multiply together to give me a times c, which in this case is positive 15, add to give me b, which is negative 8. Anybody have an idea? Two numbers that multiply together get positive 15, add to get negative 8. Listen to y'all doing some participation today. In. Yes, that works on both sides. Negative 5 times negative 3 is positive 15, and negative 5 plus negative 3 is negative 8. And your A is 1, so we don't even need to divide and slide, right? So I'm just going to go straight back to my problem, make my two parentheses. One set I'll have an x minus 5, and the other one an x minus 3. So now everything's completely factored, but don't start multiplying it all together. Cancel out what you can and see what you have left. So I can cancel out x minus 3. I can cancel out a 9x. Does anybody have to take the PERT for anything, the math PERT for anything? So a lot of y'all, if you maybe want to do dual enrollment next year, you have to get at least a 114. And that's to get into the lowest level of dual enrollment math course, and then it goes up from there. What we're doing right now with the multiplying rational expressions, dividing them, we're going to be adding and subtracting and simplifying rational expressions. If you are good at that stuff, you should do very well on the PERT. Okay, so before you take it, come back and review what we've been doing, like what we're doing the whole rest of this section. Okay, because the PERT loves that stuff. All right, so in the numerator, all I have is a 5. Say that 9x didn't cancel, then I can multiply the 5 and 9x together because they're both monomials, right? But it did, so I have 5. In the denominator, all I have is x minus 5. X cannot equal. What we said from the get-go, we had 9x in the denominator for both fractions, so we said x can't equal 0 from that. And then when we did keep, change, flip, we ended up with x squared minus 8x plus 15. Well, that factored to x minus 5 times x minus 3. So we are going to get restrictions from that as well. X cannot equal what? 0, 5, or 3. Julio? I mean, do we need to do more? Are you sure? Just like multiplication, just that one extra step, and you got to pay more attention to your restrictions. Yeah, you want to do another one? Because, well, even if you look down here, 9x, if x was 0, 9 times 0 would be 0. Somebody said negative 9, and that's common, but 9 times negative 9 is negative 81, not 0. So if it's just a monomial with a variable, it's always going to be 0 from that. Are we sure we don't need to do another one? Want to do another one? One more. Okay. We'll do. So example 3, I'm starting a new page. You don't have to. Let's do 1 divided by a minus 8. So I already know I'm going to have a restriction of 8. It says 1 over a minus 8 and that is being divided by 8a minus 40 all over negative a squared plus 12a minus 32. So that denominator is negative a squared plus 12a minus 32. Okay, there we go. So it is division. So I'm going to keep my first fraction the same. I'm going to replace division with multiplication. And I'm going to write the reciprocal of the second fraction. All right, so multiply numerator times numerator, denominator times denominator. So 1 times, I don't need to write that, but let me factor negative a squared plus 12a plus 30 or minus 32 over on the side. It does not have a common denominator. However, the leading coefficient is negative. When you're factoring, you do not want the leading coefficient to be negative. So even if there's nothing else to factor out, you must factor out a negative sign, and that negative sign does not go away. Y'all keep making your GCFs go away. Not everyone, but a lot of you, no matter how many times I say it doesn't go away, you make it go away and your problem's wrong. So when I factor out a negative, technically -1 is one of my factors, okay? So I'm going to factor out a -1, or really just need a negative sign. When I divide every term by -1 to see what's left inside my parentheses, we know all that's going to do is change the signs of each term. So negative a squared will become positive a squared, positive 12a will become negative 12a, and negative 32 will become positive 32. Now we define a, b, and c because what we have inside parentheses is still a quadratic, right? So we may be able to factor that. So we know a is equal to 1, b is equal to -12, and c is equal to 32. So on our t-chart, we're going to need two numbers that multiply together to give us positive 32 and add together to give us -12. -8, -4, let's see. -8 times -4 is positive 32, and -8 plus -4 is -12. Perfect. And am I going to need to divide and slide? No. Okay, but I had that negative on the outside, right? So my factors in the numerator, I've got a -1, and then I have an a minus 8 and an a minus 4. If you forget that -1, your answer is going to be wrong. Hunter, I need your eyes open, paying attention, taking notes, please. Hunter. Tristan, can you tap his desk, please? Wake up. Denominator, a minus 8, can I factor that? Nope. Bring it down. How about 8a minus 40? It's linear. So when you have linear, you don't do t-chart divide and slide. Does it have a GCF? Or 8? 8? So I'm going to factor out an 8. And what's left? A minus 5. Okay, y'all cool with that? So a minus 8s will cancel. And that's it. So in the numerator, I've got a -1 times a minus 4 all over 8 times a minus 5. Now really, they would not write a -1. They would probably write the negative like right next to the fraction, and then a minus 4 in the numerator. And in the denominator, they may leave it as 8a minus 8 times a minus 5, or they may write it as 8a minus 40. Either way, same thing. But if you forget that negative sign, it's not right. Yes. Did I not rewrite what? What do you mean the positive one? What? And somebody come point out what you're talking about. I have no idea. Yeah. The 1? Well, I could have, but I would just have a 1 times whatever. And when you multiply by 1, it doesn't change anything. So, I mean, you could write it there, but it wouldn't change anything, so I just didn't write it. Like 1 times 5 is just 5, so you know what I mean? So I would have had 1 times a minus 8 times a minus 4 times negative 1, and just negative 1. All right, so let's think about our restrictions. Okay, from the original problem, a minus 8's in the denominator, so we know a cannot be what? 8. The negative a squared plus 12a minus 32, that was in the denominator originally. It moved to the numerator, but it factored out as negative 1 times a minus 8 times a minus 4. So that negative 1, we would not get a restriction from that. From the a minus 8, we would get a restriction of 8, but we already have that written down. And the a minus 4 would give us a restriction of what? 4. And then our final denominator, the a minus 8 would give us a restriction of 8. We already have it. The number 8 is not going to give us a restriction because there's no variable with it. And a minus 5 will give us a restriction of what? 5. Yeah. 8, 4, 5. Yeah, that's right. Okay. Are we good? Do I need to do another one? Yes. The 4 came from, okay, so originally negative a squared plus 12a minus 32. It was in the denominator originally. So anything that was ever in the denominator, I got to look at for restrictions. So, but it's easier to get the restrictions from after you factor it. And when we factored that, it factored as negative 1 times a minus 8 times a minus 4, which was, if you go down to that third line where everything's factored. So that gave me, from there, that gave me a restriction of 8 and 4, because it's not the numerator, it doesn't end up in the numerator, in the denominator, but at one time it was in the denominator. So I had to look anything that was ever in the denominator. When you're multiplying, nothing ever moves around, right? But dividing, it does. So that's the tricky part. All right, do I need to do another one, or you want your assignment? I'm okay to do another one. Okay. And if you were not here yesterday, I recorded a video. Well, actually, the notes were from Friday, and then the assignment was yesterday. But the video is on Friday, Schoology. So please label this classwork dividing rational expressions. Of course, you must show your work. You'll always do. Circle your answers. I don't care if you circle them, you highlight them, put a bubble around it, something. Make it legible, make it clear, and circle it. And then also don't forget to state any excluded values. And like this first one's going to be so easy, don't make it difficult.